Okay, welcome to part 2 of the nervous system. There we go. Actually, the special senses. It's part 2 of special senses. We're going to go over hearing and vision today. So hearing involves the movement of sound vibrations through the ear until they reach a specialized region in the inner ear where nerve impulses are generated by cells that detect mechanoreceptors. So if you remember, taste and smell were chemoreceptors. They detected chemical changes. And then feel or touch was part of these mechanoreceptors. And then now hearing is also mechano. So it's mechanical. Something is actually moving for you to feel a nerve to generate that nerve impulse. The nerve impulse travels to the brain where they are interpreted as sound. Here is a picture of the eye. You've got the outer ear, which includes the parts you can see, and then the ear canal. Then you have the middle ear, which includes the 3 tiny ear bones. And then you have the inner ear, which includes the cochlea, and then the nerve, the auditory nerve that goes all the way up to the brain, okay? You also have the eustachian tube. That's what this is down here, and it connects down to your throat. So it's just a thin, narrow passageway to release some fluid and pressure and things that can build up. If you've ever ridden on an airplane or gone up the mountains and feel that pressure build, it's that eustachian tube that's getting the pressure. So you have your outer ear. We have the auricle. It is the visible portion on the ear on the side of the ear. It is composed of cartilage. So you can actually, move that ear around and feel it, and it moves pretty good, kind of just like at the tip of your nose and stuff. So it's cartilage. It holds its form, but it can move. So we've got the auricle. It actually captures the sound from the environment and directs them toward the auditory canal. So that's what kind of these grooves are, kind of canyons there. They help to collect the sound. We have the auditory canal then. It is lined with hair and wax. So it is this tube that goes in, lined with hair and wax. It assists in the passage of sound waves to the middle ear. It provides protection for the ear as particle debris and dust are trapped in there by hair and wax. And that part's part of the integumentary system, remember? So part of that protection, keeping things out of the body. Then we've got the middle ear, which is includes the tympanic membrane, also known as the eardrum. It is the structure, the first structure of the middle ear, and it vibrates with sound waves and passes the vibrations. Let's see, this is the first time I'm doing this on a screen. So here is the eardrum. It's pretty cool looking, and it looks like a drum. So if you hold it this way and beat it a drum. And then it has the 3 middle ear bones attached to it, and it goes, it attaches just like that in there. So these auditory ossicles, those are those 3 little bones behind the tympanic membrane or the eardrum, and it continues the passage of sounds. This includes the malleus, the incus, and the stapes. I need to change that. It's stapes, no L. And it amplifies the vibrations 20 times. So we're getting that vibration from the outside, getting it a lot more at this point. And then it'll be easier to detect what those vibrations are. So the malleus is also sometimes called the hammer. So in your note, you need to write hammer. And then the incus is sometimes called the anvil. And then the stapes is sometimes called the stirrup. And so I don't know if you can, let's see if we can see this here. It's behind me. So see that little stirrup there? That would be the stapes. Yep. And then the anvil kind of looks like an anvil. Okay. And then a little hammer. So that's why they just kind of nicknamed those that. then you have part of that middle ear, the eustachian tube. So the eustachian tube, if I can get this back in there, is this part down here that takes it down to the throat, okay? A small tube extending in from the middle ear into the throat. It helps to equalize pressure inside the ear. One good thing to remember is if you're going up the canyon or you're taking an airplane ride, you can chew gum and that'll help to release some of that pressure. Babies, especially babies on airplanes, have a bottle ready for them, and so that sucking motion will release some of that pressure too and help them out. But it can be very painful. Okay, then we have the inner ear, and it is consists of the cochlea, which is a snail-shaped structure. Snail-shaped structure composed of a series of membrane filled fluid canals that continue to pass along the sound vibrations. So on our guy here, this is the cochlea. So it's kind of like a snail through here, and then it's got all these weird fluid-filled canals. It reaches, those vibrations will reach until it gets to the organ of Corti, and that is where the nerve impulse is generated. And so this yellow kind of stocky thing coming off the side, that's the nerve that goes to the brain, and the impulses are transmitted to the brain where then they are interpreted. So, and which lobe? Do you remember which lobe they're interpreted in? We learned that already. Hopefully you said the temporal lobe, so the ones that are closer to the ear. So that is where that nerve impulse then gets sorted out and stored. Okay, there are 2 videos. I will put them on this at the end so that you can watch them, or you can go back and watch them now. No big deal. Okay, you have a picture of this on your form. I do make the students in class write, kind of draw it out so they can actually physically put it on paper and kind of see it more and know the structure. So you will need to know all the structures here, including the auricle and the ear canal or auditory canal here. You will need to know the 3 different bones here, and that is it for the ear structure. Okay. Okay, next we're going to move on to vision. So we did a colorblind test. I'm going to throw that also on your the video sheet or things to do. It's actually a PowerPoint that I have and I go through, and it's fun because the first year I taught this, we actually caught a kid in class who had no idea he was colorblind, and it was pretty fun to be able to diagnose him. And then he actually did go to the doctor, and they determined, yeah, he was definitely colorblind. But he always wondered why his family teased him all the time when he wore clothes or stuff and couldn't quite get it matching right. But pretty fun. So vision, it's the sense organs that respond to light are the eyes. The light waves travel through the eyes until they reach to the back of the eye called the retina, where the nerve impulses are generated by specialized cells that are sensitive to light. So these are called photoreceptors. So photo is light. So the vision works by photoreceptors. It's the only one of our senses that works this way. The impulses will travel to the brain where they are interpreted as visual images and provide much information about our external world. So here is some labeling of the eye. You have the pupil, which is the black, the iris that surrounds that pupil. The white part that you see is called the sclera. Of course, you have your eyelid and eyelashes. Then if we look at a side view of the eye, the front outer layer is called the cornea that covers over kind of look like where the lens would be and most of the iris. And then And then just below, so in here you've got the pupil and the iris. And then just right in there you've got the, so this is the iris here, okay? You've got capillary bodies, or ciliary bodies, sorry, right here. And it's kind of the muscle that attaches around the iris. Okay, then you have the lens, and this is actually pretty cool. It's a thick, really hard disc. And so the light has to go through the cornea, through the lens, and then back down here, and then it hits back here in the retina. And that's where it catches the images and sends them to the optic nerve down through here. Okay. The cornea, the way this is shaped, helps to determine if you have 20/20 vision or not. So if it's concave or convex, it'll make you either nearsighted or farsighted, therefore giving you the wonderful opportunity to have to wear glasses or contacts the rest of your life, like me. So you also have these muscles that are attached to the sides of the eye, upper, lower, and side. And so that helps you to move your eye all around in different directions. Okay, so the eyelid is a structure composed of skin, muscles, and lashes. Protects the eye from foreign objects by the blink reflex. So that's the whole reason why you have the eyelids and the eyelashes, is to keep things out. It also moves tears along the surface of the eyeball to keep that eyeball moist. You have conjunctiva. Conjunctiva is a membrane lining the inside of the eyelids and the eyeball. So you could turn your eye inside out like that, right? And then that inner layer that you first see is the conjunctiva. And the blinking, you know, if you were to blink and there wasn't moisture or a real smooth layer there, it would cause friction. But because you got that smooth layer, it reduces the friction when blinking. And so we can blink all the time without even realizing it. It is interesting, if you've ever gotten something in your eye, how irritating it is just to have even a tiny speck of something in there. Okay, here's another picture of the eyeball. So you can see the occiput of the orbital bone here on both sides. Yep, the sclera, iris, cornea. Lens back in here behind the pupil. Okay, you also have lacrimal glands, and they are paired almond-shaped exocrine glands, one for each eye, that excrete the aqueous or watery layer of the tear film. They are situated in the upper lateral region of each orbital. So upper, above, lateral, further away from the midline. And they produce tears, which then flow into the canals that connect to the lacrimal sac. From that sac, the tears will drain through the lacrimal duct and then into the nose. So that's why when you cry too, your nose will start to run also too. So they're kind of all joined together. You also have meibomian glands, which are a special kind of sebaceous gland at the rim of your eyelids. And it produces an oily substance that prevents evaporation of the eye's tears. The meibum prevents tears spillage onto the cheeks, so it traps the tears between the oiled edge and the eyeball and makes the closed lids airtight. There are approximately 50 glands on the upper eyelid and 25 on the lower eyelid. So you might have noticed when you tear, so you can tear often, and you can get a bunch in your eye before it does start to spill over. And at some points too, it can drain or get absorbed back into the eye. And so you can sometimes fake or get away with crying without people seeing. Okay, so the sclera is the white part of your eye. It provides protection and shape of the eye. Okay, so the sclera is the white part. The cornea would be this clear cover in the center, clear disc. Allows light waves to enter the eye. It helps to prevent the light waves. It bends the light waves onto the back of the eye or to the retina. You have your iris, which is the coloring of the eye. This is the first year I've had this eye model. Let's see what we can do here. Okay, so we're going to take out the cornea. Okay, and then you have the iris. Okay, so the iris is the colored part, and it regulates the size of the pupil to control the amount of light entering the eye, so that the iris can get smaller, and it makes your the iris gets bigger, and it makes your pupil smaller, or the iris can get smaller and make the pupil bigger. And then the pupil is the black center opening in the center of the iris is the passage for light. So if you go outside, your pupil will get smaller because it's letting less light in because it's usually so bright. If you go into a dark room, the pupil is going to get bigger to allow more light to come in so that you can see better. And then the lens is a transparent disc-shaped structure located behind the iris and the pupil. So I don't know if you can see this. Okay, so that is the lens, and it's a kind of a thick disc shape. If we can get to a eyeball dissection at the end of next week, you'll be able to feel it and pull it out of the cow's eye. And then the lens is and then it actually focuses light waves back into the retina. Okay, the retina then is the most inner eye layer of the eyeball. Ooh, eyeball's rolling away. So this innermost layer is located under the sclera, contains photoreceptors that, when stimulated by light, generate nerve impulses, and then which are then sent back to this the optic nerve that will then go to the brain, and this goes back to the occipital lobe. Okay, so you've got that retina, optic nerve, lens, iris, cornea out front. Okay, we're going to quickly go over the diseases that you guys need to know. However, yeah, you're going to have to just write these on the back of one of the pages. We're going to have them in class do a little kind of group little project for these, but these are the only ones you really need to know. Nearsightedness, when a person sees near objects clearly and distant objects blurry, occurs when the physical length of the eye is greater than the optical length. Symptoms include blurry vision of distant objects, squinting, eye strain, and sometimes headaches, treated with concave lenses or LASIK surgery. Hyperopia, this is farsightedness when a person sees far objects clearly. I'll leave the rest there for you to go ahead and write down. Stop it and write down. I'm about out of time. The bell's going to ring. Sorry. Presbyopia. Oh, dang it. Let's see. Oh, can I go back? Presbyopia is the normal loss of vision with old age usually. So symptoms are similar to farsightedness. I remember for me, it was 40 years old. As soon as I hit 40 years old, my kids would hand me something and I'd be like, oh, I just had to get it in the right place to even see it. So presbyopia. And then conjunctivitis. If you remember, itis is inflammation. And so this would be inflammation of the conjunctiva. And so that's that lining of the eye and then the lining of the skin on the inside of the eye. So this is actually caused by viruses like bacteria or fungi or allergies. Most common could be a viral infection. It's often called pink eye. So that's what it is when your eyes get really goopy. Sometimes they get like pus in them and can get crusted over. And you do usually need some sort of antibiotic to clear it up, and just got to really keep things clean. Don't, if you have contacts, be sure to wash your hands before and after putting in your contacts or taking them out. Follow strict, measures for that to keep them clean. I remember when I had children, little babies all the time changing diapers. It was the worst because and there's like little kids just have germs all the time. But you just need to remember to wash more frequently. But I would get some terrible eye infections, probably because of those contacts, putting them in and out with my hands just not completely clean. So luckily those days are over. No more diapers. Okay, and is that it? Middle ear infection, otitis media. So this is that ear infection. Most common symptom is an earache. You'll see kids pulling or tugging on their ear. That is a great indication they have an ear infection. Antibiotics, again, you can just stop it and write in what you need to. Deafness is another one to kind of know about. And one of the videos of hearing talks about the 3 types of deafness. So awesome. That is it, you guys. We are done with our notes. I will put everything in the modules and we'll be testing ASAP. Love ya. Hope you guys are doing great. Miss ya. See ya.